I have finally come to understand what lies at the edge of our solar system. It is not the empty void you might imagine, but a realm where hundreds of thousands of worlds, each more than 100 kilometers across, drift silently in the dark. Alongside countless smaller asteroids, this is the farthest frontier ever reached by human probes. A frozen abyss where even the sun's light grows too faint to warm the dust. Astronomers call it the Kuiper Belt. How did it come to be? Is there still more waiting to be uncovered in its shadows? Whether you have ever thought of venturing there or not, today I want to take you on a journey to this vast region and the stories it holds. The Kuiper Belt is no ordinary collection of rocks. Stretching across billions of kilometers, it is a ring of icy fragments glowing faintly like a halo of frost around the solar system. More importantly, it is a time capsule born 4.6 billion years ago, preserving the primordial building blocks of planets, comets, and perhaps even of life itself. Here dwell not only Pluto, Eris, Haumea, and Makemake, the dwarf planets, but also countless other mysterious bodies that continue to fascinate astronomers. Let us dive together into this shadowy corner of the solar system, piecing together clues from frozen debris that may one day help us understand the journeys of planets, the dance of comets, and even the origins of life itself. The story of the Kuiper Belt begins long before it was ever seen. For decades, astronomers had suspected that Neptune was not the true edge of the solar system. Something about Pluto, tiny, oddly tilted in its orbit, unlike any of the 8 major planets, hinted that it was not wandering alone, but part of a hidden population beyond Neptune's reach. In 1951, the Dutch astronomer Gerard Kuiper made a bold prediction that a vast ring of icy bodies lay beyond Neptune's orbit, a region that could be the birthplace of short-period comets. At the time, telescopes were too limited to prove his theory, and it remained an idea confined to paper. It was not until 1992, after years of painstaking sky surveys, that astronomers David Jewett and Jane Liu finally made the breakthrough. At a distance of 41 astronomical units, they discovered a small frozen body about 200 kilometers across, later named 1992 QB1. This unassuming object was like a key that unlocked the gateway to the Kuiper Belt. Pluto and its moon Charon had been observed decades earlier, but it was only after the confirmation of the belt's existence that they were officially recognized as Kuiper Belt objects. From then on, more and more icy worlds were found lurking in Neptune's shadow, and the shroud of mystery began to lift. At the frontier of the solar system lie 3 great regions: the asteroid belt, the Kuiper Belt, and the distant Oort cloud. To truly grasp the scale of the Kuiper Belt, we must set out on a journey from the Sun and compare these zones of cosmic debris. First comes the asteroid belt, a thin ring of rocky fragments left over from the birth of the planets. After passing the 4 rocky worlds, Mercury, Venus, Earth, and Mars, our spacecraft would cross into this sparse region between Mars and Jupiter, lying 2.2 to 3.2 astronomical units from the Sun. Though it stretches across a full astronomical unit, its total mass is tiny, barely 3% of the Moon's. The largest resident, Ceres, spans 525 kilometers, roughly the distance from London to Belfast, while the smallest asteroids are no bigger than a city building farther out, past the giant planets Jupiter, Saturn, Uranus, and Neptune awaits the Kuiper Belt, a frozen treasure trove at the edge of the solar system. Beginning just beyond Neptune's orbit at 30 astronomical units and extending to about 50 AU, it takes the shape of a donut encircling the Sun. Here dwell not only Pluto and other dwarf planets, but also hundreds of thousands of icy worlds over 100 kilometers wide, trillions of comets, and a haze of frozen dust. Unlike the rocky asteroids closer to the Sun, Kuiper Belt objects are made mostly of frozen water, methane and ammonia, fragments of the primordial cloud that once gave birth to the solar system. Astronomers believe these icy relics are some of the oldest materials left untouched. Since the solar system's formation 4.6 billion years ago, they were fragments that could have formed another planet, but Neptune's powerful gravity disrupted their union, leaving them scattered as a silent archive of cosmic history. The emptiness of the belt is astonishing. The average distance between large objects is so vast that even if two massive bodies pass close by, they rarely collide. Each icy shard drifts like a time capsule, preserving secrets from the dawn of planets. And beyond even this lies the Oort cloud, a vast spherical shell of icy bodies that may stretch a light year into space. Unlike the donut-shaped Kuiper Belt, the Oort cloud surrounds the solar system in all directions like a cosmic bubble. Though no telescope has ever seen it directly, its existence is inferred from the orbits of long-period comets, some of which take hundreds of thousands of years to return. The Kuiper Belt and the Oort cloud share a role as cradles of comets, but differ in scale and reach. The Kuiper Belt is home to short-period comets, returning in decades or centuries, while the Oort cloud sends us icy visitors whose orbits can last for millions of years. Together, these three regions, asteroid belt, Kuiper Belt, and Oort cloud, form the hidden architecture of our solar system's edge, revealing the grandeur and vastness of the space we call home. Unlike the Oort cloud, which no spacecraft has ever reached, humanity has already brushed against the frozen fragments of the Kuiper Belt. NASA's New Horizons probe stands as our trailblazer. On 14th of July 2015, it flew past Pluto, making history as the first mission to visit this dwarf planet. Until then, Pluto had been little more than a blurry speck of light. The images returned by New Horizons transformed our understanding. Pluto revealed itself as a world of mountains, plains, and a striking heart-shaped region known as Tombaugh Regio. Its western lobe, Sputnik Planitia, is a 1,000-kilometer-wide nitrogen glacier, smooth and seemingly active, suggesting geological processes may still shape its surface. Even more astonishing, New Horizons discovered that Pluto may once have harbored a subsurface ocean, and its moon Charon showed signs of ancient tectonic forces. Smaller moons, Nix, Hydra, Kerberos, and Styx, spun like irregular tumbling potatoes, likely captured fragments from the Kuiper Belt itself. But Pluto was only the beginning. On New Year's Day 2019, New Horizons performed the most distant flyby in human history, visiting the Kuiper Belt Object 2014 MU-69, later named Arakoth. This tiny snowman-shaped body, just 35 kilometers long, revealed secrets that had eluded astronomers for decades. Its smooth surface and gently merged lobes showed that planets were not born in violent collisions, but through the slow, quiet gathering of material in the early solar system, a process known as cloud collapse. Alan Stern, the mission's principal investigator, described Arakoth as a key that opened the door to understanding how planets were truly formed, not in chaos, but in calm. Today, New Horizons continues its lonely voyage outward, expected to leave the Kuiper Belt around 2028-2029. Though it has no confirmed targets yet, it may still encounter new worlds if astronomers can find them in its path. Meanwhile, the James Webb Space Telescope is adding its own insights. With its powerful infrared vision, it can peer through the icy crusts of Kuiper Belt objects, analyzing their composition and helping us piece together their ancient histories. And in the future, humanity may go even further. Robotic missions might one day land on these icy relics, scoop up samples, and bring them back to Earth, just as Hayabusa 2 returned grains from the asteroid Ryugu. Within those frozen fragments may lie untouched material from 4.6 billion years ago, a treasure that could help us unlock the mysteries of life's beginnings. The Kuiper Belt is far more than a scattering of ice and stone at the edge of the solar system. It is a cradle of planets, a birthplace of comets, and a time capsule holding the earliest memories of our cosmic neighborhood. Within its frozen vault lie the same raw ingredients that once built worlds, stirred the tales of comets, and perhaps sowed the seeds of life itself. Though its mass has dwindled over billions of years, stripped away by the migrations of giant planets, scattered by Neptune's gravity, or eroded by collisions, the Kuiper Belt still preserves echoes of the solar system's youth. Each object, no matter how small, is a silent witness to the time when the sun and planets first emerged from the primordial cloud. New Horizons has shown us only a glimpse of this hidden realm. The James Webb Space Telescope is now peeling back further layers with its infrared eye. And in the centuries to come, humanity may send landers, drills, and return missions to capture samples from these icy bodies, fragments that could tell us not only how planets were born, but also why life exists on Earth at all. The Kuiper Belt remains a frozen relic, yet it is alive with meaning. It whispers of ancient migrations, cosmic collisions, and the gentle assembly of worlds. With every new discovery, we come closer to reading the solar system's story written in ice. And one day, as our technology carries us ever further outward, we will open this time capsule completely and finally understand how our cosmic home began.